On Wednesday, March 19th, we saw a very impressive mid-latitude cyclone, which brought all different types of weather to parts of the Midwest, especially, but also reaching down into parts of the South. We're going to be looking at what caused this weather. In particular, we saw severe weather, pretty much a blizzard in Iowa, and other conditions throughout parts of the Midwest. So in this video, we'll be looking at what caused this, what went according to the forecast, and what did not. The main thing that we saw with this event was actually the severe weather. That was the main thing I covered, at least. And in particular, in Illinois, we saw a good amount of tornado reports happen. Although we have seen a few more tornado reports pop up down here in Indiana. We all had an EF1 in Gary, and I believe we had a few little QLCS tornadoes here in Chicago. So for the most part, this was not a bust day by any means, but I do want to talk a little bit about why this ended up being more of a wind-driven day rather than tornadoes. At least it was not nearly as much of a tornado risk as we had nearly expected in the beginning of it. You can see a very wide variety of severe weather, 122 reports here being shown. Here is the current actual data, 170 storm reports, unfiltered, it looks like. So plenty of still storm reports to be filtered through and all that. But this was a prolific severe weather day. We also had a lot of snowfall here. This is from the Des Moines Register. We had a nice graphic they made here. Um, Over a foot of snow in some portions of Iowa. Much of the state was actually under a blizzard warning that morning. So we did see a lot of snow in this region, and especially gusty winds as well. And another interesting weather phenomenon we saw is actually muddy rain. This happened a lot in the Midwest. This is a picture I took actually from our radio sound here on campus. I'm from Valparaiso University. We were launching a balloon that day. You can actually see all the muddy rain here. If we go back to another picture I have here, this one professor's bikes, actually, you can see all of this mud rain that stained this bicycle. That's the part she cleaned, but you can see the rest of this, lots of mud all over the place here. So muddy rain was definitely something a lot of people saw, and many actually dirty cars happened after these storms rolled through. So let's look at our weather for this now. We actually still have a RAP model from back then, and you can kind of see the progression of this trough. This surface low forming at the upper levels of a very intense trough, negatively tilted for the most part. A big part about this also was the cold core nature of this trough. You can see how cold this was aloft. Some of the much colder temperatures remained behind back here. You can see in our region over Iowa, we have negative 25 degrees over a broad portion of this. And this overspread the region throughout the day. If you remember from my videos that I made, I actually talked a lot about how this is a very traditional cold core setup where you would see, well, I'll draw this on, let's put this on the blank map so you can kind of get the idea. The idea is you get a surface low that is formed next to an upper level low within very close proximity, and your warm front becomes occluded from the cold front. And what the most favored region for storms in that case ends up being right here near the boundary of the warm front. And we talked a lot about this. This is in Davies et al. 2006 publication. If you want to look that up for yourself, this is where you'd be most likely to see severe weather on a cold core day like that. And you often wouldn't need very high dew points. So you'd only need mid 50s, low mid 50s for that severe weather to occur. In our day, this is actually what it looked like to be happening. However, as we got closer to this day, you would notice a very clear difference here, right? So here's our kind of cold front dry line. We're gonna call it a dry line for the sake of this video. That might not be 100% accurate, but for the most part, this is similar to a dry line. We saw that the wrap was kind of overdoing this setup, and the NAM was underdoing it a little bit as well. We'll use 12Z wrap. That's fine. Usually in cold core setups, you'd expect to see storms up there near the warm front. We saw this on the instability on the RAP model. However, what really ended up happening is we often saw this moisture not nearly as extreme as the RAP was showing, which didn't help, but also this cold front ended up being a lot larger, and our storm motion vectors end up being more so parallel to this boundary. Let's go closer to the event. Here's 15Z. Here's our moisture again. Let's see. There's our storm motion vectors. But a lot of these storms were not able to completely get off of the front. You see pretty weak overall flow, and as this dry line kind of became a cold front, you would end up really choking off any storms that were trying to get discrete in form. You'll probably be able to see this on our radar, actually. Let me go to let's see if I can get back past radar data. Exactly. I am using the SATRAD right now. Let's zoom into the Midwest here. We'll go There it is, right here. We'll watch these storms form, and you'll see a lot of them become discrete. Now, if we look in the visible here as well, I'll put on visible and radar here, and you'll see we had a lot of these storms that are trying to form out in this open warm sector here. Let me put the radar reflectivity on. So you can see a lot of these storms are able to form, but the main front eventually ended up getting to them. Here's that main front, and really ended up stopping a lot of that discrete nature. Really got a messy storm mode as well. So there wasn't a lot of time for these storms, and another big issue we saw as well was the cloud cover. Now, we actually needed cloud cover a lot for this setup, so looking at this in the morning, I did quite like to see that. However, a lot of this convection ahead of these, the main area of interest was a lot stronger than we expected. You could see, let's see if I can get my radar back on here. I believe there were, oh, you can see the blizzard warning back here. We got a few elevated cells up here in northern Illinois. They never really got severe warned, but we did see a lot of pretty intense downdrafts, which definitely didn't help the air that was, the air mass back in here. So we did see that kind of that struggle because of these early morning storms. For the most part, though, we did see a very unstable air mass to follow, as is indicated by these very quickly developing cumulus convective storms on the back end of this. You can see on the day cloud face how quickly these do reach our higher levels, to the point where they're becoming ice clouds up here. That means we're hitting pretty high levels of the troposphere right after this air mass goes through. But a lot of these ended up forming, and they didn't really stay discrete enough to really see that tornado threat that you'd expect to see from this setup. We definitely got tornado warnings pretty quickly here. In particular, near Peoria, we had a lot of tornado warnings right in this little vicinity. And a lot of these storms ended up becoming severe warned, and some tornado warnings here after they became more linear. So in all, we did see a decent risk day compared to what we had, but not as much of numerous discrete cells as we had really expected to see. That, again, mostly due to that early morning convection. Let's look back on our this here, just to see how that blizzard really came into effect as well over Iowa. Here's a 15Z initialization, and right at 18Z is probably our best time frame for this. You can see a lot of this pretty cold air, nearing freezing, but you don't have to be at freezing at the surface to have snow, to keep that in mind. Let us watch. Let's go to precipitation types, just so you can see how deep a lot of this was. Pretty impressive signature there. You can see it on the, on here as well. The white area here is that blizzard warning. As we move through with time, you can see this really large band of snow here for much of this region here. Very large snow band that basically stayed pretty stagnant over many regions. So very intense snow over that area, and that ended up leading to a lot of really heavy snowfall. You can see on the RAP model especially, just very heavy area of snowfall, even higher than the RAP was expecting though, because we did see over a foot of snow in some locations here. The blizzard conditions come from high wind gusts as well. You can see here, if we look at about 18Z, we have 38 knot wind gusts here sustained over much of this region, upwards of 50 in some locations. And that is very much within the frame that you'd expect to see with the blizzard. Blizzards are within that. I believe they have to be above 38 miles per hour, if I remember correctly. Maybe 35 miles an hour, I believe is what it is, of wind gusts. And we were definitely within that region, considering these very high wind gusts we were seeing out here. And that's about it for the snow. There's not much else to explain. We did a very deep DGZs, I do believe. Yeah. Our dendritic growth zone. Let's go back to our RAP. Let me just take a sounding so we can see what this would look like. I'm going to have to adjust this to a winter sounding after the fact, but you'll see kind of the idea looking at a snow profile. And yeah, it could be a little more impressive, but you can see that a lot of our region does stay within, oh, we cannot see that at all. A lot of our region stays within the confines of the -12 to -17 dendritic growth zone throughout much of the profile here. There could be a little more impressive if you wanted. We could have a little bit more of a sounding that went somewhat like this. That would have really helped snowfall, but we didn't end up seeing that, and that's okay. But you can definitely see this decently deep dendritic growth zone in there that would help cause this snow to just get bigger and all that. So we did see that synoptically as well. And lastly, I wanted to mention the dust. Actually, first I wanted to look at the radar actually, because it's an interesting progression. In particular, we saw numerous tornado warnings up here. These are mostly QLCS warnings that the NWS issued. And they often do that when we have a line of storms approaching, just to make sure that, like, I mean, because you don't know when a spin up could happen along the line. But you can see this destabilization. I'm curious a little bit as to why this really blew up after dark a little bit. It looks like after we got to that nighttime phase, some of these more discrete cells, especially across Indiana, at least originally before they got eaten up by the line, did retain some tornadic signatures out here. I believe I had a confirmed tornado over here somewhere in Indiana, if I remember correctly, with a correlation coefficient bump up. But you can see here, these storms did pretty quickly become linear, just looking at the radar presentation. A lot of congealment. They just didn't stay really discrete enough to maintain supercellular characteristics. They did eventually conform into that QLCS here, especially over portions of Indiana here, you can see, but they did fall pretty quickly due to that. Oh yeah, and I want to talk about the mud rain as well, so let's look at that. True color. I don't want that. Let's go back here. You can see the morning of, actually, let me see if I can go any further back. Let's try that. Here's the morning of our event here. Now we're gonna have pretty large time frames, about 20 minutes between each picture here. But you can see the morning of this event. Let me actually zoom out. I want to zoom out a little bit here. You can see, let's go back. There we go. Perfect. The morning of this event, you can see definitely a very clear upper level low. Lots of convection, not convection, but lots of cloud cover here. That's where we saw that good snow band going on. Also, all that early morning convection. But the main reason we saw that mud rain was due to this really large area of dust. You can see it very clearly on the true color radar, and this is honestly really impressive. So a lot of this dust was actually going into the updrafts here of this early morning rain, kind of early morning rain showers there over much of northern Illinois. And as your clouds form, right, because you can imagine you have a cloud and it's forming up into a little storm. You have all this dust that's getting into this updraft. That's a drier air, but although impressively, these storms did retain a lot of their stronger characteristics. But due to that, you end up with a mixed kind of mode here, where you end up with that dust. Oops, I cleverly deleted that. There we go. That dust gets in, and eventually you end up with water and dirt combined, which becomes mud rain. Mud as it falls out of the cloud. And that's how we saw a lot of this. That really happened over a very broad region. It was honestly very impressive for the setup, in all seriousness. So that was pretty impressive. And again, as I mentioned, with severe weather, there was a little bit of a struggle with the moisture. The route models were definitely overdoing it, so I do apologize for going a little bit, not like going overboard. I didn't want to mention that we did follow a lot into the NAM and the wrap, and this event definitely did play out as expected. If there's anything I can improve on, I think it would be I didn't pay enough attention to the linear possibilities of this event really. A lot of these storms became linear very quickly, and likely due to just mesoscale differences as storms form. But especially here, we saw a little bit of a squall line really form, kind of punch right here in northern Illinois. It's on the suburbs over there. So we definitely saw that. So I do apologize. I did miss that a little bit. But as a whole, I believe this forecast stayed pretty accurate. And really the storm system as a whole was just very impressive. And I really wanted to talk about this. So I might go into a later, more in-depth, pretty far in the future. But I just wanted to take a little bit while just to really look at this setup. It was a really impressive trough. We had all hazards of weather really in it. We had a dry line, we had a cold front, warm front, occlusion, as well as pretty impressive instability, thunderstorms, really of all hazards as well. Snow, blizzard conditions. It was really just a perfect storm of all these different factors that kind of work together. So I think this is definitely a very impressive low pressure system for at least my memory. So with that, thank you all for watching. If you have any questions on this setup or anything you'd like me to clarify, feel free to ask. So, but with that, thank you all for watching, and I'll see you all next time.